Today on Building the Open Metaverse.
My goal was to just make the users' lives easier. We realized that a lot of users just want their image out. They don't necessarily have the time to go deep into rendering.
Welcome to Building the Open Metaverse, where technology experts discuss how the community is building the open metaverse together. Hosted by Patrick Cozy and Mark Petit.
Hello, everybody, and welcome back to Building the Open Metaverse Season 6, the podcast that showcases the community of artists, developers, researchers, executives, and entrepreneurs who are building the Internet of Tomorrow. My name is Mark Petit, and my co-host is Patrick Cozy. Patrick, how are you?
Hey, Mark. Doing great. As you know, I'm a bit of a graphics geek, and within graphics, my favorite subfield is rendering, which is why I'm so excited that joining us today is a pioneering figure in the computer graphics industry. The co-founder and head of innovation at Chaos. He is the mastermind behind VRay and Chaos Vantage. Vlado Koylazov. Welcome.
Thank you. Thank you, Patrick. Thank you, Mark. Thanks for inviting me. It's honored to be here. I've known Mark for a long time, so it's a good opportunity to catch up.
And today we'll be discussing your incredible journey, the innovation that you've brought to the industry, and what's next for Chaos. And as you know, customary on the podcast, we'd like to start with discussing about your journey to the metaverse.
Probably my very first impressions of computer graphics were when I was a kid. I don't know, maybe fourth or fifth grade. I had this book about computer graphics. So it had explanations of what ray tracing is. It had some images of like glass spheres and all kinds of things that look really, really interesting for me. So it discussed the original Tron movie and the effects that they did for that film, and I just thought that was fascinating, and I thought that that's something that I want to do at some point, maybe. I guess later on things like games, like 3D games started happening. There was Doom, then there was Quake. And I realized that I was not really that interested in the game itself, but rather in the technology behind it, how it was done, and also just having this idea of a virtual world where you can go and visit with other people at the same time. It was just fascinating for me. So I just wanted to figure out how this is done, how it works. So I guess that's how it started.
So you started as a production company, if I remember well, and then what got you to develop VRay back at the time?
So yeah, originally before I joined the company was doing production. I think one of the other co-founders at that time, Peter Mitev, wanted to go into software development because he was a developer. So he asked me if I wanted to work on some projects. After some back and forth, I decided, so okay, let's see what we can do. And the first thing that we did was this little plugin for 3ds Max called Phoenix. It's not the Phoenix that we have today. It was a different plugin. It was still designed to do sort of fire and smoke effects, but it was really, really simple. But then it was a moderate success, I guess, for us back then. Even just seeing something that you wrote being sold and being used by other people, that was super exciting for us. So after that, we started working on VRay around the time that also other renders started popping up. There was Brazil, there was Final Render. There was Arnold, the very first version of Arnold. So I thought this was really, really interesting. And I wanted to see if that's something that we can also work on. So VRay started, and eventually it kind of overshadowed the rest of the business.
I believe VRay 1.0 came out about 2002 after 5 years in development. I mean, could you share some of the key challenges during that period?
I showed it to some people at SIGGRAPH 2001. We had our first reseller was a company called Digimation. There was this guy there, Paul Prashal. Maybe your listeners would remember him. yes, he later started TurboSquid. But we showed VRay to Bo. He said, and he said, this looks really cool. Maybe you should turn this into a product. So that's what we did. We worked on it a little bit more, and then we released it as a product.
So VRay 1.0, I mean, it had ray tracing, it had global illumination, it had shaders. I mean, in hindsight of those features, what do you think made the biggest difference?
It was a pure ray tracer. We decided early on that we don't really want to do any hybrid rasterization / ray tracing thing. It was going to be ray tracing all the way. And I think that proved crucial because it allowed us to render a lot more complicated scenes than you would be able to do with a ray tracer. The other thing that turned out to be really important at that time was that we had actual 3D motion blur right from the start, which was quite a difficult, and it still is. It's not the easiest problem to solve, and we spent quite some time trying to figure it out. So that was also crucial for VRay. And we also decided early on that we will have physical lights and physical materials, partly because it also made it possible to do optimizations that otherwise are not possible. And I think the biggest advantage that VRay had is that it had these different global illumination engines that it could combine in different ways. So you could use brute force, or you could use a combination between brute force and something else like a photon map or a light cache. And this combination of techniques actually allowed VRay to be pretty flexible. And it turned out that our customers actually like that. They like to have the different trade-offs between performance and quality. And later on, I realized that this decision to give them the choice was actually pretty important.
I took over the 3ds Max team in 2002, and we had this partnership with Mental Images and Mental Ray inside the package. And so, I'm like, okay, fine. And I knew that because we had Mental Ray in Softimage as well. And so I knew that, and then started to work on that. And then you guys show up with VRay, and I was like, okay, well, the VRay shader seemed to be physically accurate energy conversion, way ahead of its time. So, I think the shock came in 2005, with VRay 1.5, when you guys starting to introduce all of those new features like light portals. Remember that? And then the sun sky system, so you made it absolutely easy for accessible visualization, something. And for me, I had to fight. I'm not going to name names, but it was incredible how that approach at the time, was completely new and almost revolutionary, because it was really about, building inside the renderer the trade-off so that it becomes very easy for the users to do stuff. And, we were desperate, and we're trying to discuss with our friends at Mental Images, right? Why can we do that in Mental Ray? And then for some reason there was a mental block said, no, it's a shader. The user has to take care of that. So I think it was for me at that moment, we probably realized that, VRay would win the world of architectural visualization forever, because that ease of use that you brought, that innovation was absolutely fantastic and way ahead of its time. Do you recall the story this way?
So I was worried a little bit at some point. But at the same time, competition is good. It always keeps you on your toes. So you always try to make things better. So again, from that point of view, it was probably for the best. But to your point, I think very early on, my goal was to just make the users' lives easier. And we noticed that they spend a lot of time not just on the rendering process itself, but on building their scenes. And anything that actually helped them to get to an image faster was valuable. And this didn't necessarily have to be strictly rendering technology. Like you mentioned, the sun and sky system. So these are just procedural direct light and procedural environmental texture. But users really need these kind of tools to be able to build their images a lot faster. And the same with the VRay material. Yes, you could probably just give the users the components to build a new material. You could give them separate diffuse, reflection, refraction components and let them create their own shader. But we realized that a lot of users just want their image out. They don't necessarily have the time to go deep into rendering.
I want to underline one thing you said. It was incredible that, you got the whole industry to pay for VRay while there was, a free render and a free ray tracing alternative shipping with 3ds Max. And I think it was quite a feat, and to achieve that, and it's a testament to, how important it is to be user focused and to bring people what they want and make things simple. I think, to be fair, the mental rega, they always wanted to optimize for flexibility and let people do whatever they want. And I think it was, in hindsight, it was probably not the best choice. So
for some users, flexibility is very, very important, and I recognize that. But and we do have some of these users as well. But honestly, most of the time, people just want to get a nice image out.
Were you the one behind those decisions about, making the VRay material the way it was? It was those early days. I mean, energy conservation, this was really, really new and really innovative. And you kind of had, a lot of trade-offs to make that shader works for almost everything. So was this you, or how did they come to pass?
The idea for the VRay material, actually, I looked at the existing ray trace material in 3ds Max, which had some level of energy preservation in it, not completely, but it was a good starting point. So, and also I realized that the math just doesn't work if the shader is not physically accurate. I wanted to implement a technique called multiple importance sampling in VRay. And I think actually VRay was probably one of the first commercial renderers to use this technology. But for this to work, the materials and the lights need to be physically accurate. They need to preserve energy. So there was just no... I was also kind of forced to do it this way. So it wasn't so much a conscious choice as just a necessity. And it took a while also to figure out, like, there were some different approaches that you could take, like how the different components interact with each other, diffuse, reflection, refraction, and which component is, like, if you turn everything up, if you make all the components full strength, what happens? And this was also probably the choices that I had to make, but I think ultimately they proved to be more or less correct. Like, not everything. We occasionally still have to update something or another, but overall it seemed to be a robust way of creating materials.
I think one of the recent news from Chaos was the support of Blender, which has a very strong rendering as well. It's a free package. So why did you choose to support Blender? I think it's fantastic news for the Blender community.
There was this developer who had actually implemented an integration of VRay and Blender all by himself using the public VRay SDK. Andre, he now works for us. And we thought that this is an interesting idea. But the integration was not maybe ideal. Part of it's not exactly a problem, but just because Blender is open source, and VRay is not, this creates a little bit of a challenge for us. I myself, I would love to get VRay open sourced as well, but the fact is that we can't just afford to do it right now. So we had to figure out some intermediate layer where the open source part would talk to the closed source part. And this is not very, very easy to do in a good way. And then, so we had this for a while, but then Blender changed radically. The SDK was completely different. So what we had as code didn't work anymore. And for some time we were debating whether we should spend time on rewriting everything or not. But eventually we saw that Blender is really on the right path. And more people were starting to use Blender for all kinds of interesting purposes. And maybe 2 years ago, about 2 years ago, we decided that it seemed to be the right time to go back to that project. So we took the source code, we updated it for the latest releases of Blender, fixed a lot of issues, and hopefully later this year we'll be ready to give users something that they can play with.
A few years back, you announced Project Lavina, which I think was the goal is to bring VRay into the domain of a real time. And Project Lavina became Chaos Vantage. It seems like it's gaining significant traction in the industry. So I'm very familiar with Unreal Engine here, and we know that game engines like Unreal, they achieve their speeds by implementing systematic trade-off, to favor speed over precision. So what kind of trade-off are you making to get, VRay to run in real time? And where do you think Vantage is in terms of quality compared to game engines?
When we started working on Vantage, so that was immediately when NVIDIA announced that they will be doing hardware ray tracing. So, and this will be available through DirectX as well as the optics APIs. So we thought that like I said, my very early experiences with computer graphics was games. So I kind of always wanted to, at some point, go back to real time, maybe. And I thought that was a good time to see what this new technology can do and whether it can bring us closer to real-time ray tracing. And we did this experiment in 2018, trying to ray trace a large scene with lots of trees, lots of instances, and global illumination, reflections. And it actually worked pretty well. It was clear that we would need maybe things like denoising or some other optimizations just to get to real-time frame rate. Because even today, we can only do a few rays per pixel. It's not like in a production renderer, you may need hundreds or thousands of rays per pixel. So hardware is still not as fast, but there are now a lot more tricks that we can do. But I think the biggest advancement there was all the denoising techniques that came out around that time. They were crucial for making real-time ray tracing possible, and also various sampling improvements. Like if you have only a few rays to trace, you have to make sure that they are the right rays that contribute the most to the image. So there was a lot of research going into that, how to trace things with many light sources, how to sample GI more effectively. So all these advancements happened that made real-time ray tracing possible. But the trade-offs that we had to do initially was in terms of features. Mostly we knew that we just cannot do in real time everything that VRay can do. So we had to be very careful with the feature set that we support. And then as hardware got faster, then we would add the missing features bit by bit. But always keeping in mind that it has to run in real time. Other than that, there aren't really too many restrictions in terms of actual lighting calculations, in terms of formulas and mathematics. Vantage is really close to what VRay does. So the quality of the lighting is the same. It's just various things that might work in VRay but not in Vantage. Some, for example, procedural textures. With VRay, people can do these complicated shading networks that can compute a lot of stuff on the fly. With Vantage, this was not possible, so we had to be really selective with the shading nodes that we support. Also, environment effects like volume lighting. We decided early on that that's going to be something that we would look at sometime later in the future.
I want to come back on DLSS, deep learning, super sampling, because I think that was a revolutionary moment. And I thought you were the first, non-gaming product to incorporate DLSS 3.5. So Can you tell us what kind of speed up you guys with that? I think it's and maybe explain what it does to our audience, because I think it's the magic of AI at work here.
DLSS is actually an awesome development because it combines several things in one. Denoising is just one thing that it does, but it also does upscaling and also anti-aliasing, which are both crucial for the performance. With other denoisers that we had up to that point, you still had to render the same resolution image, and the denoiser would just remove the noise. But also solving the anti-aliasing problem, if you only can do one path per pixel, then you can't really get a whole lot of anti-aliasing performance out of that. And while you can do stuff with temporal accumulation and things like that, it's just complicated to get it right. And the DLSS denoiser just combines all these three features: denoising, upscaling, and anti-aliasing in a very powerful way. Specifically, the upscaling is important for real time because it allows us to render at half the resolution. So we basically have a quarter less pixels. Basically, speed goes maybe up close to 4 times frames per second. So that was crucial.
Yeah, you basically render 1 pixel and guess, 10 or 12 pixels around it. I mean, this was absolutely fabulous.
We probably could not have done by ourselves because it requires first a lot of training data, then a lot of computational resources to build a model, and of course a lot of know-how. And it's just very nice from NVIDIA to do this research and make it available.
Kudos to NVIDIA for giving us that technology.
So what about VR? The hardware capabilities tend to be quite different between desktop and VR. Does Vantage do VR?
We are working on VR right now. We have internal prototypes that work quite well by this point. So hopefully this will be in an official release at some point soon. And yes, you're right, the requirements are different, and the frame rate is very, very important because otherwise there's real discomfort. And I myself really don't feel very comfortable wearing VR headsets. So for me, that particular problem is very important to solve correctly. And there are a few tricks that we had to do. The upscaling denoiser helped a little bit, but also things like reprojection, where you can just generate intermediate frames. So you don't have to actually render every single frame that comes on the VR headset, but you can also interpolate between actual rendered frames. That's also very important.
So let's talk about another form of immersion. You launched recently Project Arena. There is a very interesting video of you and your friend Mikhail, the CTO from Chaos, about Project Arena, which is your solution to bring real-time rendering to virtual production on LED stages. So I encourage everybody to go look that video. I think it's time well spent, and you actually do talk about some of the challenges that you had to overcome. But can you give us an overview of the problems you wanted to solve to get Project Arena going?
We were always, as a company, interested in virtual production, even before we had the real-time ray tracing engine. We tried to do experiments in 2015 with Kevin Margot and his Construct project. He, at that time, was working at Blur, and they were doing a lot of game cinematics and a lot of motion capture. But the thing with motion capture is that while you were doing it, motion capture mode, you have no idea what the virtual world is like and where the actors are in it. Basically, you have to have it in your head, like what the whole scene looks like, and then hope that you're doing the right thing. So Kevin's idea was to find a way to visualize that motion capture data in real time, both the environments and the virtual characters driven by the actual people in the real world, actual actors for motion capture, but be able to see all that in real time along with the camera. So we tried to do that with the technology that was available at that time with GPU ray tracing, and it sort of worked, but it wasn't really practical at that time. Just the hardware wasn't nearly fast enough, and we didn't have the software advancements that we have today, like denoising. So we kind of left the project at that point. And then in the beginning of last year, 2023, we already had a real-time path tracer. So we thought about what other applications we could have for it. And virtual production came to mind. We decided what it would be like if we went back to that project and tried to do it now. But this time we decided to focus on LED walls, which was something that was relatively new. It wasn't really a thing back in 2015. But virtual production on LED walls seemed to be gaining traction. And it was a really good use case for real-time technology. And at the same time, we had conversations with customers who were it was taking a lot of time for them to convert their environments that they built in their usual DCC tools, which would be Max, Maya, Houdini, or whatever, and prepare them for a real-time experience on an LED wall. And we realized that we already have all these VRay integrations into different products, and we can already export those scenes very well into VRay scenes, and Vantage can read VRay scenes. So the idea was that we would try to take that existing technology and use Vantage to drive an LED wall with proper camera tracking and everything. So that's how Project Arena started.
Visual production right now, this is the hallmark of Unreal Engine. There's probably many stages running Unreal in virtual production. So you mentioned the workflow advantage, that the data probably flows more easily into Vantage than with much less conversion than anything else about, you taking up the competition there and bringing new capabilities and stay ahead in the real-time domain compared to those game engines?
First of all, just to mention that Unreal is great. It can do so many things. There is a lot of technology that's been built into Unreal over the years. So we don't think that we can replace Unreal for all use cases, but we do believe that there are certain use cases where our solution has an advantage, and I think those cases are exactly where there are teams and people who want to use virtual production, but they just don't have the know-how or the time or the knowledge to do the conversion of their project to a real-time situation. And this is where we believe that Project Arena can actually help, because going from a DCC to an LED wall just happens in a matter of minutes. With practically no conversion, and you get results that are very, very close to what you originally built. And this is where the advantage of Project Arena actually is. And we think that this workflow can actually open virtual production up to people who didn't have the ability to use it before that.
Shout out to Chris Nichols, who was running your lab in Los Angeles, has been a virtual production advocate and fan for many years. He's also, Patrick, a fellow podcaster. He's been doing podcasts since the beginning of podcasts. I think he's one of our one of the OJs of podcasting for computer graphics. So shout out to Chris.
Getting close to 500 episodes.
Yeah, no, we're babies, Patrick. We're complete babies right here.
But he's been pushing for virtual production this whole time. Like, he was over the years, he's been asking, like, we should do something on virtual production. I was always like, yeah, it's complicated, and then it's a lot of work and whatever. But then, like I said, the stars aligned in the beginning of last year. So I thought, well, let's try this again.
And now, look, it makes a lot of sense. The workflow with everything on the stage, turning around new scenes. And so I wish you luck with the Project Arena. I think it definitely complements very well a lot of things that you can do with Unreal. So
So we wanted to talk a bit about your role. I mean, as the head of innovation at Chaos, it sounds like the ultimate dream role. I mean, could you tell us a bit about your responsibilities and areas of focus?
At some point, VRay just became way too big for one person to manage. So that's when we started up building different teams that focus on the different VRay integrations. So I didn't really have to work that much on VRay for 3ds Max or VRay for Maya and so on. And I could just focus on the actual rendering algorithms, VRay itself. So that's why we built an R&D team that was just looking at rendering technology. And originally, this was mostly about VRay, but obviously, then we had Corona and now Enscape. So the role of the team grew beyond just developing new technology for VRay. With everything that's going in the area of artificial intelligence, we decided to build a dedicated machine learning team. So last year, we went out and tried to find and hire some very smart people who have been working on artificial intelligence for a while, so they could help us bring our products to the next level. So my job right now is overseeing all of that new development. So not just new rendering technologies and optimizations and new products, but also how we can use artificial intelligence.
Outside of AI, you've been mentioning, working on rendering, still working on rendering and sampling. Is there a next big thing we can expect in rendering? I know the Weta guys work on diffraction rendering for some time. I mean, what's your vision there? Where do you think the rendering field is headed?
Almost everything that you can think of has already been explored in quite a lot of detail. So the things that are not covered yet are the really, really difficult cases that we have no good solutions. And I mentioned caustics. That's still a hard problem to solve. More realistic materials, and obviously you can optimize things for as much as you want. So I guess in terms of rendering, there isn't really a next big thing, just a lot of small refinements on existing techniques. And for me, the biggest advancements will come from workflow improvements and just being able to build your scene faster. And then there are any number of techniques now, any number of render engines that can turn that scene into a nice image.
You mentioned a bit about scaling your engineering team. I was curious, how close are the VRay and Enscape teams working together? And do you think over time, the Chaos products might converge into one rendering engine?
As you can imagine, we have quite a few renderers now, and every now and again we go back to that question. But ultimately, I don't think that, at least at this point in time, and with the technology, both hardware and software that we have today, I don't think there's one render engine that can do everything and do it well. There are, like, the analogy that I like to make is with different car models. Even one car manufacturer has these different car models, and yes, any car can take you from place A to place B, and they kind of all work in a similar way, but there's a reason why there are different models. There are like more powerful cars, bigger cars, but they're also lightweight. They're also electric versus diesel and so on. So there are reasons why different render engines are needed. And at least for the time being, I think it's just not possible to have one solution to rule them all. I think that's the dream, obviously, but it's just not practical at this point of time. And the example, probably the clearest example, is between maybe Enscape and VRay. Enscape is a very lightweight renderer, very fast for a very specific purpose, and it works really well. But you don't really want to turn Enscape into a VFX renderer just because it will not work. As you start adding features, the renderer gets more complicated and slower and more difficult to use. And it will just kill the original purpose of the render. So that's why I think having solutions that are tailored for specific use cases is the best way to go right now.
So let's switch to AI. Where do you see as the big impact that AI can have on you mentioned scene generation and automation. Can you elaborate on that?
There are several use cases for AI. The most obvious one where the AI can help with image enhancement. I think that's at this point pretty much an accepted fact, and we see customers using AI to augment their final renders every day. One good example is CG people. Those have been traditionally really difficult to do just because it takes a lot of effort to do realistic human in 3D and to render it out. Traditionally, oftentimes customers will just Photoshop pictures of like photos of real people on top of their renders. And with AI, this actually can be done pretty well. You just need to have a decent or a semi-decent 3D model of a person in your image, and then with some AI manipulation, it just becomes this very realistic person with a proper skin tone and hair and everything. So this is happening every day, and it's an obvious application of AI. And obviously, not only people, you can do the same with vegetation and other parts of the image. And this is also something that we are working on, and how we can bring this type of image enhancement to our product. But there are also any number of tools today that can do this as well. There's Magnific AI, there's also Crea AI, and we see people use them more and more. Beyond image manipulation, however, I still think that it is valuable having your scene as an actual 3D scene, because if you have an image that you like, but then you want to turn it into animation, or you want to look at a different camera angle, then you need the 3D information. Or if you just want to, like with AI specifically, directability is a problem. If you just want to move things around just a little bit in your image, like move the object in a different position, that's not very easy to do with AI these days. So it's either you like what you get, or you just type in another prompt until you get something that is usable. So from this point of view, 3D content is actually very easy to manipulate in some sense. And unfortunately, it's also not an easy problem to apply AI to. Right now, the machine learning methods that we have at our disposal need a lot of data to work. So that's why you need billions of images and text to train something like Stable Diffusion.
You mentioned stylization and material creation using AI.
Materials are definitely an interesting topic, especially some types of materials, like different type of wood, different type of stones. Having a large library of materials helps, but you can't really have an infinite library. So being able to generate materials based on some user description is very valuable use case. And also there are different ways to approach it. One way would be just based on a text prompt, you could generate an image that, like a set of textures that the user can use. I think that's also one of the differences compared to image generation. You have to generate several textures. There has to be a diffuse map, there has to be a roughness map, also a normal map or a bump map. And this is an interesting problem to figure out as well, how to generate all these textures. So they make sense together. But also, not just from a text description, you can, for example, if there's a photograph that you like and there's a material on that photograph that you like, maybe it's possible to just click on the image and say, I want this material, and then the software could recreate it for you. That's also an interesting way to go about things, and something that we want to explore. So far we've done some promising research, but we'll see where it goes.
So we wanted to talk a bit about USD and Material X. So, Mark and I are involved in the Metaverse Standards Forum, and, we're paying a lot of attention to open standards and universal scene description, USD. Has been gaining a lot of traction, for sharing and describing 3D scenes. Was curious about your perspective on its adoption. And we also noticed that Chaos joined AOUSD. If you could talk about your motivation there.
USD has been interesting for us, I guess, from the very beginning when Pixar open sourced it, because it seemed to have the need for a common standard graphics format for scene exchange. That need has existed for a long time, right? It's not something new. It's been around for years and years, and there have been various attempts to solve it with various file formats. I guess that the most recent one before USD was Alembic, which kind of tried to solve this problem to some extent. So the need was there. The only problem was that all the solutions had various kinds of drawbacks. And with Alembic specifically, the drawback was that first, the use case was very specific, but also the standard wasn't strict enough, and different applications ended up writing things into the Alembic file in different places with different names. And even though in theory you could exchange data between applications, in practice it was not really that simple. USD kind of promised to solve all these problems, and standards are really only as good as the number of companies that support them. And the stars happen to align around USD, that a lot of people realize that this is maybe something that they can use. And not only in the area of visual effects where Alembic and USD were originally created, but also for all kinds of other applications, including architecture. And you see today companies like Trimble and McNeil integrating USD in SketchUp and Rhino, which is great. And for us, as like VRay is generally, and not just VRay, all of our products are basically one part of a larger pipeline. Our products are just one portion of the workflow for our users, and we need to be able to exchange information with the rest of that workflow. And it's super important for us to integrate as smoothly and easily as possible with the rest of the tools that our customers are using. And USD seemed to be the natural choice for that, especially as adoption grew with the various other tools.
You had your own representation. All the Chaos products talk through a format called VR Scene. Were you ever tempted to open source VR Scene?
We have thought about it, but open sourcing something is really not enough to make it successful. It requires a very conscious effort to draw up support for your solution, even if it's open source one. And I don't think Chaos as a company can do that. Somebody like Pixar or LM, they can do that, but it has to be somebody that has some weight in the industry and somebody that people would rally behind. And yes, I've thought about the VRay scene file, but it's really a very specific format that was originally done for VRay, and there's a lot of stuff that it doesn't really handle. So we only store in VRay scene files, we only store the information that's needed for rendering, but there's a lot of stuff in the 3D scene that is just there so that people can manipulate it more easily. There's the hierarchy of objects, all kinds of additional metadata that people need to work with the scene, but is not needed for rendering. And the VRay scene format from that point of view is maybe not the most suitable thing, whereas USD was designed in a way that it can be extended with this additional types of information.
So conversely, could you see VR scenes, fade into the sunset and being replaced by USD even for internal Chaos product communication?
It's possible, certainly something that we have thought about. It's not the right time yet for this, just because USD is still in development. There are still new portions of the API being figured out, and that's why we joined the USD, right? Because we want to keep track on the development of USD so that our products are as prepared as possible for the evolution of the standard. But at some point, when things settle down a little bit, then yes, I can totally see USD becoming the format for using 3D data, even internally for our own tools.
When you look back at everything you've been doing in computer graphics, is there something that stands out as a significant achievement so far that you're particularly proud of?
Implementing the light cache in VRay, I think was pretty important because this is what actually made it useful for architecture, and it helps to get this realistic multi-bounce lighting, especially for interior scenes, which made VRay so successful. Again, very related, but I really like the way that the original VRay architecture was designed. It's not perfect by any means. I've done a lot of stupid things in retrospect, but even so, it's been like over 20 years now that this overall software architecture still works, and it allows many people to work on the code at the same time. So I think that also turned out pretty well. Of course, if I started today, I'd probably do it slightly differently, but like for a newbie, I think it went pretty well.
So to wrap things up, is there a person or persons or organization you'd like to give a shout out to?
All my colleagues, to be honest, that there's a lot of work that goes into our products, and that like the amount of just code that we've written over the years and the ideas that went into that code, it's really amazing. And I just cannot stress enough the contribution of everybody. Building a successful product is a team effort. A lot of people involved, development, but also everything else around it, sales and marketing, and it's just an enormous effort. And if you don't have the right people, then nothing happens. So I think we were very lucky in this regard.
So big shout out to the team mostly in Bulgaria.
Well, we're a bigger company now, so yes, the Sofia office is probably the biggest one, but we have people all over the world.
So Vlado, it's been a privilege to chat with you today. You're a pioneer in computer graphics, the co-founder of Chaos. Your innovation with VRay Vantage are revolutionizing the industry. You've been setting new standards for rendering technology. It was fun to see your commitment to pushing the boundaries of what's possible, and you continue to inspire and shape the future of visual effects, visualization, and now even virtual production. So thank you for being with us today, and thank you for sharing this incredible journey and those insights with us.
Thank you. Thanks for inviting me.
Yeah, thank you, Patrick, and a big thank you to our ever-growing audience. You can find us on all the podcast platforms, and you can reach out to us on our LinkedIn page or on our website, www.buildingtheopenmetaverse.org. Thank you, everybody. We'll be back for another episode. Thank you.